Let's hear it for Zarathustra and Boma.
Hi, guys. So we worked on consensus client performance profiling. Both of us had the similar interest, starting off with Grandine and branching out a bit, as you do during work on a project. There's a couple of repos listed there. 2 of them are on GitHub, because that's where everybody else is. And I myself prefer GitLab, so I threw that in. I'm going to hand it to Boma, who's going to take the first bit.
Okay. Hello. Hello. Okay, sorry. My name is Messi, and I'm here to make a project presentation. Although our project shifted a little bit, the initial goal was to work on security and testing, but due to some, I underestimated some things, and so I had to focus on performance analysis, a comparative analysis between the consensus client. Okay. So, okay. Sorry. So the initial goal was to do a security and reliability of Grandine, and then there was a shift in focus which transitioned to profiling multiple clients due to technical challenges which I faced. Oh, okay, sorry. So first of all, I used so many performance security tools. The ones that stood out to me was a flame graph, and then implementing a timing matrix on Grandine. This is an example of what a flame graph looks like. Although it's not quite readable because you have to like click in and then out to really view. But okay. So looking at these stacks, Grandine is actually performing very well from the stack overview. Although there is a drop down from the Tokyo runtime, which is at 61.79%, which had a minus 35% drop down. So the key observation here is there is a high trend utilization on 97% in system trends and initial setup, significant drop down to 62 in Tokyo runtime operations, and then a consistent performance across Tokyo task management. Also, multi-threaded worker execution showing similar patterns in different narratives. Okay, sorry. So this is the 35%. Looking at the system trade level, which is 97%, then the Tokyo runtime, which is 62%, and then which identifies the 35% drop down. So the cliff there is kind of huge, and the high performance areas are trade initialization, system level operations, and then co-trend management, which Grandine pretty handled very well and then performed very well in that aspect. So areas of investigation, okay, a disclaimer, this is a research project. It's still, I will call it a research because so many things can change and then I might be wrong in some cases. So the areas of investigation for me is the Tokyo ties scheduling, which is at 62%, and then the sign runtime overhead and the tax profiling efficiency. And talking about the timing metrics, which I had to implement, for now, Salus suggested that I had to do a comparative analysis between Grandine and then Lighthouse. So for now, I only have the data on Grandine, and I'm yet to produce the data for Lighthouse to properly do a comparative analysis. But this is basically how the data looks like, and I'm hoping to use this to do more investigation on to do more analysis on formal verification and fuzzing, creating a targeted fuzzing and what's it called? Primitive analysis. Sorry. And hold on. So the reason why I had to use tools like the frame graph and the timing metrics was to help me understand more about the consensus client, because I really underestimated what it is to force and build a fuzzer for a consensus client. Because coming from a smart contract security background, I thought it was the same perspective, but I was proven wrong, and the complexity was overwhelming. But using this analysis and using this data, I think I'll be able to produce and to come up with a strategy in order to have to build a fuzzer, which has to do with making it a targeted fuzzer, and also for formal verification. because I understood that there is no much work on formal verification on Ethereum consensus client. Thank you. I can hand it over to you.
So, small premise to the second part. So, as I mentioned, we initially started working on Grandine. There was a slight shift in focus, transitioned to doing this profiling of multiple clients. At least that was what I focused on. DevOps emphasis. I decided to go there since I have no experience doing any sort of DevOps work, and I figured having a couple of months seemed like a lot of time here. That's a good thing to pick up. So that was fun. Built my own server from secondhand part. First time doing that, running Proxmox. Pretty interesting experience. Learned a lot. Challenges, hardware constraints. I thought I had sufficient amount, but turned out that maybe the minimal required specs listed are not entirely enough to run all the nodes on a single server, at least not the one that I decided to assemble. And regarding the outcome, yeah, well, there's limited data. The results are modest, but valuable insight into running Ethereum nodes was acquired. So let me tell you a bit about the setup that I used. So I listed on the left side for you guys the consensus clients that are there and the versions of those that I used. Two of them don't have a version specified, and that's because I didn't manage to run them, so they were not included. I would like to include them at a later stage when I have the capacity to do so. In terms of hardware, I have dedicated 8 cores to each of these. RAM, 32 gigabytes, and the disk space is 2 terabytes, NVMe drive, which is sufficient for all these clients to not be limited there. In the setup, I make sure that each of them running on a virtual machine is limited to this, basically. So there's no way that if one of the VMs isn't using all of its RAM, that one of the others could use it because it's available. This is normally something that Proxmox supports, but that, of course, doesn't allow for a proper comparative analysis. Then the services that I also got to work with and got to learn about, and Nethermind, of course I needed an execution client, and a whole bunch of other services that anybody who has done anything in DevOps probably knows. So Prometheus, obviously, for metrics. I'm not going to mention them all, but I will just say that these were a lot of tools that were new to me. Quite interesting to see how many services you actually need to run such a node in a useful way, so that you actually can monitor what's going on. Then I'm going to show a couple of figures on some of the data. It's a bit older data, but so be it. So this is the CPU usage that I measured over the course of about a week, a little longer, for 4 of the consensus clients that I mentioned. And now the question obviously is, what does this mean? And I don't have a crystal clear answer to you. I do notice some things, which you'll probably also notice straight away, which is that Grandine seems, on the average, to have the lowest CPU usage. But there's somewhere a spike in the middle. I see that in a later figure, in the next figure I'll show as well. And honestly, I'm curious what happened there, but I simply don't know. I probably need more data. From the metrics alone, it's not so clear. It could be various things. It might be something network related, could be something client specific. Simply don't have an answer for you there. Here I looked at the memory usage of the different clients. Also, you see the same spike in the same period, but it's for a different client. So yeah, there's definitely something going on there, and I would say that my suspicion is that it has something to do with my server at that point, since I see this weird pattern. But like I said, I have no straight answers for you. And then the last figure I will show. I think this is actually one of the things that is highly relevant. I only show Grandine and Lighthouse here, because the initial focus was more or less on Grandine, and well, for comparison, also taking into consideration Lighthouse. So the number of pairs that you have is obviously very important. And you can see that there are actually quite large spikes to the downside. I have the limit set at 100, so that's why it looks kind of artificially kept there. But yeah, if you lose a lot of pairs, that's obviously not a good sign, and well, it seems to be fairly, maybe not stable enough, or not as stable as you might want it. So in terms of outlook, what I would like to do is refine and scale this node management. So I now have almost automated setup for the provisioning of my VMs. I would still need to switch to NixOS or Talos to have it fairly immutable and idempotent. Then I want to integrate ETH Docker. This is something that I simply didn't have enough time to properly look into. So far what I've been using is Sedge. Well, I started with simple scripts and running local binaries, and eventually went on to use Docker Compose. But yeah, I would like to move to Kubernetes, and I would like to also explore ETH Docker, because I think it offers some of the things that I was lacking or missing in Sedge. And then I only very recently, that is to say yesterday, learned about the secret shared validator. So I'm going to look into this. This is something in the direction that I was thinking. I want to use this setup. I want to use this setup myself with an agentic system, because there I have a background. So I think it might actually partly at least overlap with the secret shared validator setup, because I was thinking in that same direction. And lastly, I want to optimize the data queries, because the idea of this agentic system would be to integrate those metrics so that the agent can proactively take the necessary measures. For example, manage your node. If you see that your peers are getting too low, maybe you need to, well, do something to fix that. Yeah, that is all I have for you. So then I only have a thank you slide left. Obviously, Mario and Josh, it was amazing. Thanks so much for well, all the time and effort that you guys spent and granting us this opportunity to be part of the EPF. Yeah, I think that's it. So if there are any questions, then. Boss, yeah.
Hey, thank you for an amazing talk. I was wondering if the nodes that you ran were validators or just nodes?
No, also validators.
Also validators.
Yeah.
Okay, so it might be nice to see the difference between, for each client, what's different if they're a validator and if they're not.
Yeah, I agree. There's lots of experiments you could do.
Yeah.
Really lots more. I would have liked to have done more of them. But it's, as Boma already said, it's quite overwhelming, because even when I thought I had all the pieces and sort of working, and then you need to learn PromQL, okay, and then you learn a bit of PromQL, and then you see all the metrics that are there. For example, Grafana, which I also used a little bit at some point, I just decided, okay, I just cannot do it. So, yeah, I agree. There's lots more. And those things would be interesting to look at, yeah.
Yeah, amazing. Thank you.
Any other questions? Mario?
Yeah, I was wondering, because you mentioned the setup with Proxmox and then you want to automatize it, setup with Nix. It's really cool. You didn't really have any slides, like some more specs about it. Like, for example, what virtualization are you using with Proxmox? Like KVM or LXC or, yeah?
KVM is what I'm using, but I could explore maybe alternatives. I haven't explored any alternatives there. So, you think it's worth exploring?
Just the Linux containers are good for servers as well. And I was wondering, like, because Proxmox supports both, and you just, you didn't have the details there, so I was wondering, like, which one.
No, this is true. No, this I used, it's the lightweight version, right? So for Linux, that's the preferred option, I would say.
Yeah, cool. Thank you so much, yeah.
All right, thank you guys.